Welcome to video 2, where we will continue our talk on rotations. In the first video, we discussed what the rules were for 90, 180, and 270 degree rotations, but only when they were rotated around the origin, 0, 0. This video will discuss what will happen if we need to rotate 90, 180, and 270, but not around the origin, not around 0, 0. And there's two different ways to look at it. And so I will present both ways for you in this video, and you can decide which method you prefer most. All right, so I will not take off points for whatever method you choose as long as you do the method correctly. Now, the first method we're going to do is we're going to start with triangle ABC here, as you see on screen, and we're going to rotate it 270 degrees about 2, 2. All right, so first let's find the point 2, 2. Here is the point 2, 2. So we're going to take this whole triangle and rotate it 270 degrees, 3/4 of a complete revolution around this point. So that means point A is going to go 3/4 of a turn around. So A should be somewhere up in this vicinity. B is going to go 270 degrees, which should end up somewhere in this vicinity. And point C should go 270 degrees, which should end up somewhere around in this vicinity. Now again, the rules don't apply. We can't just use our x comma y transforms to y comma negative x. If you try using this rule, that'll only be if it was around 0, 0, and you will clearly tell that your image of triangle ABC will not have been rotated around 2, 2, but rather around 0, 0. Now the first method here involves still using our rule, but we kind of have to bend the rules just a little bit. We need to bend our perception. I'll actually leave that there. So whatever point you're rotating around, here's what you're going to have to do. We're going to have to pretend, okay, we're going to have to get our imagination caps on here. We're going to have to pretend that 2, 2 is really like 0, 0. So I'm going to draw in a new x and y axis, okay? So 2, 2 is really like I'm saying it's 0, 0, okay? So with that in mind, with this pretending that 2, 2 is like 0, 0, now I'm going to go figure out, well, what are my coordinates for A, B, and C if this is quote-unquote 0, 0? So point A, coordinate A, normally, if we were talking the normal way here, point A would be negative 3, 2, right? But if we're going to say this is now 0, 0, so that we can try to use our rule here, point A would be 1, 2, 3, 4, negative 5, 0. Negative 5, 0. That is the kind of imagination A, if you will, right? So where's point B at? B, is really at 5, 5, but according to our new 0, 0, it's at 1, 2, 3, 1, 2, 3. It's at 3, 3. And our pretend C, normally it's 2, negative 2, but according to our new 0, 0, it's at what? 0, 1, 2, 3, 4. 0, negative 4. Now again, these are all this thing will let me write. These are all really the pretend coordinates for A, B, and C. If we pretend that 2, 2 is really 0, 0. Now, since these are the pretend coordinates, and that we are pretending like they came from 0, 0, then we can use our rule here. We can switch the position of x and y and just switch the sign on the old x as the new y here. So then A prime would be located, let's see, if I switch my coordinates, and then I switch the sign, so that'll be 0, positive 5. B prime, let's see, if I flip 3, 3, it's still 3, 3, but I need to make the second coordinate negative, so 3, negative 3. And C prime, if I flip around my coordinates, that'll be negative 4, 0. Make the 0 negative, but 0 can't really be negative. So now I just get to go graph these 3 points. But I need to graph these 3 points using the pretend 0, 0 as my origin. If you go back and use the real 0, 0, this is not going to work out. So now, going to our pretend 0, 0, First I need to find 0, 5. Again, we go start at the 2, 2, and we move over nothing left or right, but we go up 5. 1, 2, 3, 4, 5. So right here, this is A prime. All right, so next up, 3, -3. Again, start back at 2, 2, or pretend 0, 0. We're going to go over 1, 2, 3, and down 1, 2, 3. So right there is B prime. And last but not least, -4, 0. Start back at our pretend 0, 0. And we're going to go over 1, 2, 3, 4 to the left and move nothing up or down. So there is our pretend C prime. Now, last but not least, we need to connect the dots. So A prime down to B prime over to C prime, and C prime back up to A prime. And so now there fully is our image triangle, triangle A prime, B prime, C prime. Now, this is just one way of doing this particular problem. Okay, if you have to rotate not around 0, 0. The other method involves slopes, and we'll discuss those in the next 2 examples. Now, here's what we're going to do. We're not really going to use any rules. We're going to use the graph itself. This is what we're going to have to do if we rotate about some other point other than the origin. So here's the point 1, 2. This is what we're rotating around. Okay. Now, if I line up where I'm rotating around with what I'm rotating, so let's start with point A. I need to rotate A 180 degrees, right? And 180 degrees is, if you think about it, it's going to be like in this direction, because that's 180 degrees, right? That's a straight line. So how am I going to get this point and measure that distance over to here? Well, some of you were telling me the other day that we could use slope, because this isn't really a vertical or horizontal line, but we could use slope. We're really going up 1 and over 1, 2, 3, 4. Well, guess what we get to do? We get to go up and over the same thing. Up 1, over 1, 2, 3, 4. So this point right here, let's get rid of this line now. Let's get rid of that piece. So this point right here is going to be A prime. And again, we just use slope from A to the center of rotation, which was at 1, 2. And now if you look, does it look like this distance is the same distance from there to there? It does. It should be. It should be the square root of 17. Or exactly. All right, so now let's do B. Well, B is down here, but how far away is it from the center of rotation? Well, again, let's use slope. So we're going to go up 1, 2, 3, 4 over 1. Repeat. 1, 2, 3, 4 over 1. Does it look like those 3 points are collinear, that they are all making a straight line with each other, aka 180 degrees? And if I connect the 3, they connect perfectly, so they are collinear. So B prime is located up here at 0, 6. Now for point C. Now C, you will notice there is no rise. Got a rise of nothing, but we run 1, 2, 3 to the left. So we're just going to repeat. We're going to go up and down nothing, but go over to the left. 1, 2, 3. And there's C prime. Now, is it true that C prime, the center of rotation, and C all make a straight line? Yeah, they make a horizontal line. So that is 180 degree rotation. So now let's connect the dots. A prime, B prime, B prime, C prime, C prime, A prime. And that was the type of picture that we kind of had in mind earlier. Okay, so now this triangle is rotated around this point 180 degrees. So again, that's what we're going to have to do when the center of rotation is other. All right, in our final example here, we're going to rotate a triangle ABC 90 degrees around a non-0, 0 point. Now, just like with the 180, we're going to use the concept of slope, but we got to use it a little bit differently because a 90 degree rotation isn't going to give us the same idea as a 180. And a 90 and a 270 are going to be very, very similar to each other. All right, so First, let's find negative 1, 3. So negative 1, 3. We're going to rotate everything 90 degrees around this point. Okay? Now, we could use, like in the very first example of this video, we could pretend that this is 0, 0, but I just want to show you a different way of doing this problem. Maybe you will like this way a little bit better. All right, so let's get an idea. 90 degrees, we're really going to rotate this thing 90 degrees, counterclockwise. So it's going to move counterclockwise 90. So let's just get a rough idea of what's going to happen here. So point A, if we look, it's just 3 units to the left of where we're rotating around. So this thing's going to move 90 degrees in a counterclockwise rotation. Well, if it's perfectly horizontal, what's going to end up being perfectly vertical? It should be 3 units down, right? So point A is going to be pretty easy to do, but I want to show you a little bit different method. And it doesn't really work too well with point A since it's directly horizontal of it. I'm going to start with B, and then I'm going to work with C, and then I'll come back to A and finish it. And you'll see why A was a lot easier to do. So the first thing I want to do is think of, again, the idea of slope. So from my center of rotation, everything must start at the center of rotation. So from the center of rotation, my slope, I'd go up 1 and over 3 to get to point B. Okay? What I would recommend doing on your paper, right, because this is what your paper totally looks like, right? Somewhere off to the side, you know, like on your paper, this is where example 8 is, down here. So I would put, you know, you've got some free space over here. Over here, you could make some little notes, or maybe over in the margins, or down here, down the margins. You could kind of make yourself some little notes. So what I'm going to do is kind of draw this slope, this up 1 and over 3. I'm going to draw a little point first. This represents my center of rotation. And I'm going to go kind of up and over. And that got me to point B. And so I'm going to label what those values were. I had to go up 1 and then get to over 3. So that little point lets me know where I'm starting, and the arrow here at the very end lets me know where I need to go to. Now, if I want to go 90 degrees counterclockwise, let's see, let me get everything linked up here. If we want to go 90 degrees counterclockwise, you could take your paper and turn it 90 degrees counterclockwise, just like so. And what you see here is a key that lets you know which way B prime is going to have to go. So now let's take that key and let's apply it to figure out B prime. So it says from the center of rotation, remember this was still our original point, we need to move 1 to the left and go up 3 to get to B prime. So from the center of rotation, which is right here at negative 1, 3, we're going to move 1 to the left and up 1, 2, 3. And there's B prime. Now, does it look like, if I made a quick line here in red, from B prime to the center of rotation to B, does that look like I've moved 90 degrees counterclockwise? And I'd say, yeah, that looks like a pretty good 90-degree angle. So I can feel pretty confident that I did that correctly. Now, we move on to our next point, right? Let's take this, let's move our paper back. Get rid of all that junk. And we can leave that there. You can erase it, whatever you want to do. So now let's move on to C. All right. So again, you start at the center of rotation. Let's look at the slope. We'd go down 1, 2, 3, 4, 5 over 1, 2, 3. So somewhere on the margins of your paper, just kind of small, center of rotation, we went down 5, and then we went right 3 to end up at point C. And that's our initial guide. Now, what we need to do is take that guide. My board would stop being so crazy on me. We're going to take that guide. Got to lock it into place before we do it. And then again, we need to rotate this thing 90 degrees counterclockwise. So I rotate my paper 90 degrees counterclockwise. And then I look to see what I need to do. So from the center of rotation, we need to move 5 to the right and up 3 to find C prime. So from the center of rotation, we move over right 3, 1, 2, 3, and up, right 5, 1, 2, 3, 4, 5, and then up 1, 2, 3. Here is where C prime should be. And we've got 2 out of 3 done. Now for A, as I mentioned earlier, A is going to be pretty easy because there's really only one direction in terms of slope. There's only a run. There is no rise. So if we went back and looked over here, we said we'd move 3 to the left. So you can do the same concept here. We just would draw one arrow to A, and it took 3 going to the left. So again, let's lock this into place. And we need to move our paper 90 degrees counterclockwise. And this is tell us we're going to have to find A prime by going 3 down from the center of rotation. So center of rotation down 1, 2, 3. Here is where A prime is. And so last but not least, we can use a ruler, some sort of straight edge, and connect together A prime, B prime, C prime, and C prime back to A prime. And there is our image using the concept of slopes. And again, I highly encourage you to do this type of method here. Just draw out the slopes, make sure you know which is the beginning and the ending. That's why I always recommend making a starting point as your center of rotation, and at the very end draw a little arrow cap here so that you know which is really the end point. You can put the letter representing that coordinate at the very end that represents where you're going to, then rotate your paper whatever way it needs to be rotated and however many degrees it needs to be rotated, right? I mean, you turn it 1/4 of a turn, there's 90 degrees. Oop, 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 oop. There's 90 degrees. Turn it another quarter turn, there's a full 180. Turn it another quarter turn, now there's been 270 degrees, and all the way back around is 360. So 90, 180, 270, 360 is taking it a quarter turn at a time.